Let's look into the first modules of our library and see how they fare up against Python's arrays and NumPy. The idea is to create a test engine in Python and a small REST API in S/4HANA, connect these, and call into S/4HANA via Python to create vectors and provide us the time it took from start to finish. Our library has grown significantly since we published the teasers, and we will now spend a few minutes looking at this. The starting point of our class is the matrix object, which is formed by a series of vectors. As such, we built the ZCL vector class before and made it available to the ZCL matrix class. Looking into the matrix class, we see two distinct paths, one for Euclidean spaces of R2 and R3 and another for Rn spaces. Let's look first at the Euclidean space. The first implementation is the ZCL vector, a class in ABAP that implements vector operations in Rn. The class provides support for cross-product, dot-product, element-wise operations, normalization to an origin-based unit vector, scalar operations, transpose operations, and support classes for internal arrays, toString, and shape methods, thus aligning with the same support provided by Python. At the left we see the relationship between vectors and matrices. At the right, we see the implementation in ABAP for a simple REST API. From a Python perspective, our code is simple: start a call to SAP's API just built and ask the library to create a vector for us. It will return the time taken to execute the request. We then ask Python to do the same via NumPy. We do this 100 times, varying the vector rank by a factor of 10 starting with the R2 space. Analyzing the graphs presented, we see the expected pattern giving a sense of linear growth as the rank of the vectors get bigger. However, upon looking closely, we see that the growth is not linear but exponential like the side of a parabola. The intriguing part is that our S/4HANA SAP seems to be content in creating vectors of rank 200,000 just as fast as it does for vectors of rank 200. When we overlay the graphs, a clear picture emerges. As the rank grows, the amortized time to execute is near linear until the 20,000 rank, becoming asymptotic as the rank grows. This is expected as S/4HANA does not have enough memory to allocate a vector of rank 2 million, whereas NumPy uses the almost infinite memory of the laptop. Another factor to consider is that S/4HANA is single-threaded whereas NumPy is multi-threaded. Consequently, the runtime for NumPy from rank 2 to rank 200,000 is quasi-linear. We need to consider the reality of S/4HANA and not its capabilities to replace Python, as this is not the goal here. If we inspect the graphs closely, we note that S/4HANA would suffice in creating a vector of rank 200,000, thus granting it the capabilities to manipulate eigenvectors of that rank, a fact that will become the center of the next class discussion. Not shown is the calculations using Python's arrays compared to S/4HANA. In this scenario, our library fared better for larger ranks and no worse for medium-sized ranked vectors.